Let's take a look at the tangent curve. Now, the tangent curve is actually more similar, I think, in many ways to the sine wave curve in that every reference point we take is from the zero position here. So the zero, when I say the zero or no motion position, I mean the zero amplitude position. So when we come across something like tan x, in all cases, this is asking the question, how far through its cycle does the waveform move before it encounters an amplitude of 0.34? Let's take a look. So we're going to have 0.34. Well, 0.5 is going to be right in the middle there. So 0.34 is going to be about, crikey, so 0.5 about there, I'd imagine. Okay, so here it is. I'm going to draw a line all the way along if I can, trying to coincide as many times as I can with the actual line. So 0.34, if I said, well, 0.5 is going to be in the middle there, about there. So 0.34, 0.34 is going to be about there. So the question is, where does that coincide? Well, it coincides at, and that in this case is going to be, and we know it's going to be 18.8, but let's prove it's going to be 18.8. So I can just go, and I'll do it on the calculator, but I'll just go tan x is equal to 0.34. So x is equal to the arctangent of 0.34 or 0.34. Let's see what that comes to. So 0.34. So the arctangent of 0.34 is 18 point, and I'm going to call that 0.8. 18.8. So x is 18.8. 18.8 from the no motion position. So every time I go along here, and I'm going to be encountering a zero amplitude position, to find out the next time that the amplitude equals 0.34, I just take that start point there, I take this start point here, and if I was doing it from here as well, I take this start point here and move along 18.8 degrees, and I'd come across 0.34. Come across 0.34. Now, of course, we don't know what this is here, and the reason we need this graph is because the calculator only returns the nearest, the first instance where this moves to the 0.34, moves to the amplitude of 0.34. And the first instance is, of course, 18.8. There's 18.8 degrees. Second instance is over here, and we can see it's the zero plus another, in this case, 18.8. Now, the sine wave, we actually had to move back a whole bunch of degrees. In this case, we're moving forward because the waveform is moving forward. So let's have a look at it here. So we've got 180. We're going to add 18.8, and we get 198.8. So you've got 18.8, and you're adding to it 180 degrees, and you end up with 198.8 degrees. And that is how we end up with the 2 points here. Now, I'm also noticing we've got some other points as well, and in fact we can do some rather interesting ones here. Let's go for something a little bit different. Let's go negative 1.23. That's going to be an interesting one, or negative 1.23. So here we go. We're going to find this one here. Now, we can already see the answer is going to be 129.1 and 309.1. But what does the calculator tell us? And we've got to think, again, as long as we understand what the graph is telling us, we can make sense of the answer. So let's have a look at here. So I'm going to go, so in other words, how far through its cycle does the wave pass before it comes to the first instance of an amplitude of negative 1.23? Well, let's find negative 1.23. 1.23 is about here-ish. Well, there's 1. 1.5 is going to be like in the middle here. So 1.2 is going to be way down the bottom here. Let's just call it there. So it's going to be like there, yeah? So here it is, 1.2. So let's have a look, and we can calculate that pretty easily. So we can say the tangent of x is equal to negative 1.23. Well, what does that tell us? Well, it's saying, where is the first instance of the wave as it passes through its cycle where it encounters negative 1.23? What's the closest to the zero position? Well, here's our zero position, and we go along, and it looks like it's going to be over here. So it looks like about 1.23, it's about here. So it looks like it's going to be, in this case, around the 120, oh, look at that, 129. There it is. And it also seems to be a bit later on as well. What's this one here? And it's about there as well. So it's about, looks like in that case it's 309.1. There it is. So this is 309.1. And this one here is going to be 129.1. What does the calculator say it is? Let's have a look. So we're going to find x is equal to the arctan of negative 1.23. There it is. And equal. So x, what does x equal here? Let's see what that turns out. So we've got the arctan, and we've got negative 1.23. Was that the one? Yes, it was negative 1.23. There it is. Let's see what we get. And we get, oh my goodness, 50.88. I'm going to call that 50.9, yeah? So it's negative 50.9 degrees. Well, what does that mean? I mean, the answer we're told here is 129.1 and 309.1. Remember, this graph is showing what the angles in between 0 and 360. It's not going backwards to 50.9. So why does it even give us 50.9? And the answer is simple. You'll notice the tangents are going back like this, going back like this, going back like, if we carry this on here, it would look like this here, just in the same way that these waves move. So what is this here? Oh, imagine what that would be. Well, there's the first instance. This is the closest one to the 0. So that means this point here must be back 50.9. Back 50.9. So this is negative 50.9 degrees. That's what that means. That is. Which means that every time we come across one here, this must be, if this is back 50.9, this one must be 180 and back 50.9. So I'm betting if we took 180 and we subtracted 50.9, we'd get 129.1. Let's see if we do. Let's see if that plays out. So we're going to take 180. Here it is. We're going to take 50.9 off that, and we get, look at that, 129.1. Same deal here, yeah? We've got 360. If we go back, and let's try that again, we've got 360. We're going to take 360, and we're going to go back 50.9. Where do we end up? Here it is. Let's have a look. 360 minus 50.9, and we end up at 309.1. 309.1 degrees, and there they are, 129.1 and 309.1. So that's what the tangent curve is telling us. So whenever you look at this and you're asking a question like these, because these really are questions, it's saying what is, or rather how far through its cycle must the wave pass so it finds the nearest incidence, the nearest point where, that is to the no motion or the 0 position, where the amplitude is whatever it is here. That's all it's saying. Hope that makes sense, folks.